Hello, everyone. We're back, I think, here. Sorry, catching up there on section 1.2. So hopefully in 1.1, you got a little basic idea of what we're studying here. But now we're going to try to throw a little math in here at you a little bit, at least, to try to show you why you might think some things are true or false. You're going to need a calculator for today's lesson. I'm going to show you how to do a little simulation here. Kind of showed you a simulation or chapter 6, but same basic thing. So we're going to study one little piece here. There's lots of different arguments here. So what I have here is a little chart, and actually let me cover this piece of it real quick here so as not to confuse you. But basically, I took some of the data. It was one of the round layoffs, and I believe these were the ages of the people. There was sorry about that. There was 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 10 people, these ages, and the circled ones were the ones that were laid off. Okay. So it's just 3 out of 10. I know a very small sample size. A lot of times we use small sample sizes just because it's easier to work with the math, but it can also be a little deceiving. For instance, the company, the workers say, wow, look, man, you laid off 3 of the 4 oldest people. Uh, their average age was 58, super old. Clearly, there's a problem. The company says, no, time out. Wait a second. There's only 10 people. So look, if we change one of those 55s to a 25 by chance, it's going to change everything. And that's kind of what you see in this chart here. So this first chart had the average age of all the people laid off was 58. And the average age not laid off was 41.4. Most people would just look at those numbers and say, oh my gosh, yeah, there's a problem. The company clearly laid off the oldest people. But however, if you just change one of those, change one of the 55s to like a 40, I don't remember which one I changed, you can see how it totally alters everything. So this is now the altered data. Now the average age laid off is 45, the average retained is 47, and then there's no problem, right? So when you have small sample sizes, this is always a little bit of a problem, but small sample sizes also make it easier to show you math. So we're going to just ignore the small sample size for now, and we're just going to learn some math. So what we're going to do is what's called a simulation. We're going to actually, the company's claim is, hey, we just did this randomly. And since the company claimed that, and we say, no, there's no way that could have happened randomly. The odds on that are so small that we don't believe it. So what we're going to do is a simulation to actually see what would happen in terms of probability. For this particular problem, we can actually do the math, and I'll show you how, to show what the actual probability of giving an average age over 55 was. But that's because the numbers are small. There's only 10. If there's more than 10, it's like, whoa, way too much. So first things first, a simulation is just like an experiment that you do to test what you think could happen or could not happen. So there are 4 main steps in a simulation. The first one is you got to be able to make some sort of model where randomness is the only way of being selected. You put the names in a hat. I'm going to show you how to do it on your calculator. Putting things in a hat is annoying, takes forever, right? So I'm going to show you how to use your calculator to do this. So chance is the only way to be selected. In any kind of simulation, you want to do it a lot of times. If you just do it once and say, look, it didn't happen, that's not much of an argument, right? But if we did it 100 times and it only happened once, like the situation only happened once, you have some ammunition to tell the company, whoa, no, there's just no way. But you can't do it just once. It's always pretty important to draw some sort of display of your outcomes, some sort of distribution, some sort of picture, and use what we call a summary statistic. We're going to talk more about summary statistics next chapter. A summary statistic is whatever is important for you in this problem. For now, our summary statistic is average age. Okay, we're looking at the average age. And then when you're done, you come up with some sort of conclusion, right? And what you say is, look, there was only a 5% chance of this happening by chance. If this were you, and I said, there's only a 5% chance of this happening, do you believe it could have happened or not? Or is it likely or not? And most people, I know you might argue with me, I get that. And if we were in a class, we could have a really good discussion about this. It's pretty hard right now. We probably will as we go over the homework if you have questions about this. But 5% might say, no, that's too small. There's no way it could have happened. And notice the wording here is small probability. That means chance probably didn't happen. It was 5%. So something else, or something else that caused it. In this case, they did it on purpose. And then if it's not small, yeah, okay, maybe it could be chance. So one of the problems is how small is too small. For you, it might be 5. For someone else, it might be 20. Okay. And there are some legal laws about this in terms of age discrimination. We're going to kind of ignore that right now. And we're going to use this number right now and just say this is a really, really important idea right now, that if the chance was less than 10%, we're going to say probably not due to chance. In other words, I don't believe that you guys really pulled these names out of a hat. It was less than 10%. You made it happen. Could it have happened? Yes, of course it could have happened. But we're going to say, so let's just agree, and then we'll go greater than 10%. I know there should probably be an equal sign here. Hopefully it never falls out to be 10%. It doesn't really matter. So let's go greater than or equal here. Then chance, a possibility. We're going to be very, very vague on our conclusions. Okay. We're just going to say, nope, probably not due to chance, or yeah, maybe it could have been chance, but we always know that it could be the other one also. We're going to study this a lot more later on in course. So let's do a little simulation. So here's the idea here. Basically, the idea was this. These are the 10 ages. Okay. The company laid off 55, 55, 64. They said they pulled the names out of a hat. They got an average age of 58. We say, no, I don't believe that for a second. I'm going to test this. So I'm going to do a simulation. All right. So here's how we would do the simulation using a calculator. You could put the numbers 25, 33, 35, 38, 48, 55, 55, 55, 56, 64 all in a hat and just pick out 3. But that's a little bit of a nuisance, and we're just going to use a calculator. I'm going to show you how to do this, okay? So you might remember, let me do one thing first. When we do this, remember on the calculator, we learned this thing last week called random integer. And you can put in 3 numbers. You can put in your low number, your high number, and then how many. All right? And so what we're going to do is put these, and we want everyone to have the same chance, right? So what we're going to do is assign each one of these ages a number. So this will be 1, this will be 2, 3, 4, 5, 6, 7. I'll keep referring back to this, 8, 9, and 10. All right, so I'm going to leave my screen here for just a second, and we're going to go to my calculator just so I can show you this. Hopefully this works. Hopefully that's not too bright. So remember, we're going to do a random integer. So what we're going to do is we're going to go to math, over to probability, and down to this random integer. All right. Now, this is the old software. So some of you, it's going to say low, high, and how many. My calculator does not say that. Mine just has that little blank screen. Let me actually grab another calculator here. Just so if you have this calculator, you would just say, we're going to pick numbers from 1 to 10. So 1, 10, those are the 10 employees. And we're going to lay off, remember, we're laying off 3 people. So we're going to lay off 3 people. One of the things that you might see happen when you hit enter, we got 10, 10, 2. I'm glad that happened. We got the double 10s, right? Remember, the 10 is a person, so we can't lay that person off twice. So if I was really doing the simulation on this calculator, I would just ignore that one and just do it again. So that one didn't count, okay? And I would go back to math, probability, random integer. Now, some of your, well, let me do this again. 1, 10, 3. No repeat that time. So 6, 5, and 8. I'll go back to my screen in a second. Some of the calculators have a random integer, no repeat. We'll solve that problem for you. So if you happen to have a calculator with random integer, no repeat, then you can do that. Sorry, this is a little bit bright, I know. So I'm going to go math, probability on this one, random integer, so you can see it. A lot of you are going to have this, right? Lower number. So we go 1, 10, and 3. And then we got 181. We got a repeat. We just ignore it. Go on to the next one. All right. So let's go back to this one. We got a 6, a 6, a 5, and an 8. So now I'm going to go back to my other screen here. So as I'm doing, sorry about that. As I'm doing the simulation, I would write this down. So I got a 6, a 5, and an 8. A 6, a 5, and an 8 is a 55 for the 6, a 48 for the 5, and a 55 for that. And then I'm going to figure out the average age because that's what is important here. So 55 plus 48 plus 55 equals 158 divided by 3. So we got an average age of 52.6. So their average age was 58. So what we're trying to do is run a simulation and see how likely it is to get what we say a result as extreme or more extreme than theirs. We're not just looking for 58. We're looking for 58 or higher. What's the probability? So the question now would be, what's the probability we get an average age of 55 or higher? Now, I just ran the simulation one time and I got 52.6, so I got a 0. But what you would do, if we were in a class right now, I would have you guys all do this 10 times, right? So there's 30 of you in class. Now we have 300 real quick. It would probably only take 2 minutes. And then we would then put them all together. So we'd have like 300. We'd say, oh, hey, how many of the 300 had an average age of 58 or more? And then the idea is if out of those 300, it's less than 10%, we're going to not think the company used randomness. We're going to say, nope, it wasn't random, something else. And if it's greater than or equal to 10%, so this is not random, not likely to be random, and this is random okay. So that's how a simulation works, okay? Sometimes a simulation is the only way to do it. I'm going to show you how to do this mathematically. It's pretty simple, actually, and then I'll be done. But, if there's 30 people and 10 people get laid off, there is some hard math behind that. So you just want to use the simulation. Now, a lot of you I know can do computer programming. You could do a quick computer program on this and probably whip out 10,000 simulations in a minute or less than a minute. I had people do that last year. So simulations are pretty powerful, but they're not exact. Remember, simulations are just simulations. Right? So anything can happen. But remember the law of large numbers from chapter 6. If you do the simulation enough times, your results are pretty much going to be what you expect. So now I'm going to real quickly show you how to just do this mathematically because the numbers are small enough, and then I will be done. So the question is, what's the probability of average age greater than or equal to 58? All right, so here's a little math probability for you. So first thing you need to know is how many different ways are there to pick 3 people from 10? Because remember what we're doing is we have these 10 numbers, 10 people, and we're just going to pick 3 of them. So we use this to learn this terminology back in the first chapter, chapter 6, 10 choose 3. I'll do that on my calculator over here on the side. Sorry you can't see this, but 10 choose 3 is 120. So there's only 120 ways for us to even pick 3 people here. Okay, so now it wouldn't be out of the question to list all 120 of those. You could go, hey, 1, 2, 3, 1, 2, 4, 1, 2, 5, and so on. But we don't have to do that because we don't need all 120. All we need are the ones that are going to give me an average age of 58 or more. So if you notice the numbers, it's going to be pretty easy to figure this out because the only way to get an average age of 58 or more is to include 3 numbers that are big enough. Yeah. So notice we got 55. There's no way you can put a 48 in there and have it work. So we can just count these. It's pretty easy. We can just start listing. So I'm going to call this guy 55A, A, 55B, 55C. So notice in order to get over 58, you have to have that 64, right? It has to be in there. So we just start listing. You can go 64 with a 56 with a 55A. You can go 64 with a 56 and a 55B. You can go 64 with a 56 with a 55A. All right. So now you got to say, well, are there any other cases? Did I grab them all or not? And so the one I have to check, I need the 64, but is it possible? What happens with 64, 55, and 55, right? So I do that math. And I go 64. We know that's the 58 that they did in the first place, right? So I'm going to do 64 with 55A and B, 64 with 55A and C, and 64 with 55B and C. I believe these are all of the cases. 1, 2, 3, 4, 5, 6. So there's 6 out of 120. So because the sample size was small, it was pretty powerful. I could just find that probability. I come over here in my calculator. I go 6 divided by 120, and I get 5%. So we're going to say, based on our probability, are probably not due to chance. Okay? So let me know if you have questions on that. That should be enough to get you through tonight's homework and a little practice test that I'm going to give you, just so you can kind of see how it works, see how kind of things get asked, see what I'm looking for. You can do just the simulation with your calculator over and over and over, but if the numbers are small enough, this is a pretty powerful thing just to find the actual probability. But the simulation is an important tool we're going to lose in class all year. Because like I said, once you get 50 employees and you're laying off 10, this little thing I just did right there, it's not going to work. You're not going to be able to do it. So let me know if you have questions. Have a nice day, and we'll go from there.